Hello everyone, welcome to today's session. My name is Wycliffe, and today I want to share with you how you can use nightlight data to compare two regions, right? To compare two regions in terms of how probably developed they are. Okay, so as usual, we start by loading the necessary libraries, and then we initialize our workflow or our Earth engine. If you don't know how to initialize our Earth engine or your Earth engine, then you are welcome to go and read the README file, which I have in my GitHub account where I host this. I will put the link to this script in the description of this video. So you can go there and find how to install and set up your RGEE. Okay, then we will start by drawing the features. So we say draw features. And then because of my basic understanding of this region, I know that here we have tea growing region. If I expand this area, we have this as tea growing region. And then on this other side, we have sugarcane growing region. So I want to compare the nightlight over time between two regions, tea growing region and sugarcane growing region. So I select this. I leave this area because I know it's an urban area, and that might give the high values for that region. So I just select the smallholders and I leave out the large scale tea growers, which are probably more developed. Okay, so this is sugarcane, this is tea. Done. Okay, so after drawing these features, we mutate a zone because it's a simple features. If you run zones, you will find that it's an SF object with two columns. I don't want those two columns. I just want one column called zone, which contains the name, whether it's a tea zone or a sugarcane zone. Okay. After that, if we check zones, it is now just having a simple feature with just one column for zone, and then the other one is geometric, which makes it a simple feature. All right. So after that, we can convert it simply to an Earth engine object by using this SF as EE, all right? So we have it as a simple features. The next one is to get our nightlight data. So this is the ID which we obtained from the Google Earth engine, and it's an image collection. It has got two bands. We will use the average radiation rad or AVG rad for the nightlight to indicate as the band representing the nightlight intensity. Yeah. Then we get the years which we will use from 2013 to 2024. The data is available from around April 2012. Okay. Then we will create a map. We will map through these years to create an annual image. So we create a function using PyFunction utils, and it takes a year. That year, from this list, say 2013, it's converted to an engine number, and then the start date is the first year and the first month of that year. And then the end date, we increase that start year by 1 year. Okay, so that's the total number of images obtained. It's a monthly data, so that's total images for that year. And then the annual image, we filter date with this start and with this end to make for 1 year, maybe 2013, okay? And then we hide this, and then we get the mean for that year, and then we can rename it as light with year added and formatted so that we don't have trailing decimal values. Then to the image, we can set year. All right, then once we have the image, it's a list of images because we mapped over a list of years. So we need to convert it to an image collection by using from images because there are several images in a list, okay? Then we convert it to bands. Then we will have our images. This annual image has Earth engine image with several bands, right? Then we want to reduce region so that we have annual images for our zones. So zones is our collection, and then we use a reducer of mean at a resolution, which is the best resolution for this image, okay? Once that is done, we can then convert it to a simple feature using EE as SF. So the beauty of this is that we don't have to export it and then bring it to R. we just use EE as SF without going through our drive. It's just converting it from the Earth Engine object to simple features locally in our R. So that takes a bit of time because of the reduction, but then it's done. Okay, then it's a simple feature. So we drop the geometry so that we remain with the data frame, which we can work with in using our dplyr. So the night lights collection, we can pick only columns that have light in them using this grep function, which is in base R. And then that gives us names, which we can use in pivoting, in converting our data frame. If you look at this data frame, it's wide format, right? If you look at it, it's wide format with the name T-zone and all the nightlight intensity values or the nightlight values we have for that, for the two regions, okay? We can convert it to a data frame by pivoting it, and we use all the nightlight columns except the T-zone, of course, or the zones, of course. So that's why we had this grep function up here. And then we can make names to go to band and the values to light. Then we need a column here, because if we run this alone, we will see that the column with the band has got both X01 light and then the year. Let me rerun it. The year 2013, 23, 24, 2014, blah, blah. So what we do is just to get the year and forget about this X0 light, right? So that we use this regular expression, which removes everything before the 4-digit year number and then keeps that. Then we can sort it. So if you look at our DF now, if you look at the DF, sorry, it's now a table with year and light. So this year column and this light column and zone are the most important to us. So those are the ones we are going to use to plot our night light over time. So to the ggplot function we use, which is from ggplot2 package, we use the year as integer, of course, and then on the y-axis we pick the light from this, and then we group by zone and color by zone so that we have different colored lines. We can set the line width as 1, and we have points at the intersection of X and Y axis, and then scale continuous, ensuring that the breaks for years are not decimal. And then the minimal, we set base of 14 for clarity, and we add labels for the title, the X-axis, the Y-axis. It's in nanowatts per steradian per centimeter squared. That's the unit, okay? Then we color, the color zone here gives the legend title of zone. So I can expand this and run that. So we can see that how the night light values have been performing between sugarcane zone and T-zone, yeah? So if you want to walk at night in either T-zone or sugarcane zone, it's preferable to walk in a T-zone at night. Okay, just for fun. Because they have more light, so you won't be afraid of walking there at night than in a sugarcane zone. In the sugarcane zone, there is less light than T-zone. Anyway, sugarcane is also taller than tea plant, so it's maybe better to work in the T-zone. Anyway, that is not the essence of doing this kind of analysis, but probably you are looking at development-wise between this T-zone and sugarcane zone, which region is more developed. You may be interested in other things, maybe whatever socioeconomic activity or socioeconomic kind of analysis you're interested in, but it's easy to get this kind of data annually or even monthly, because we have, this is monthly data. You can run this analysis on a monthly basis or annual, as I have aggregated in this case. Okay, so we can go ahead and visualize some clear differences. For example, this year of 2019, we see that the difference was quite wide between the nightlight in sugarcane zone and the nightlight in the T-zone. So we can use map, we can center our map at the zones, and then we zoom to the level of 10, and then we add layer where our Earth Engine object are our annual images. Then we select the band for 2019. So if you look at annual images, for example, to know the band names, if you look at annual images, $ band names, it's an ad engine list. So from that list, you can get information, right? And the information you get is 0 that, 0 that, 0, 1 that. Okay, these are the band names. So the band name we are interested in is for 2019. So it is 6/2019 as indicated here, okay? But we clip it to our zones so that each of the 2 zones has its image clipped to its borders. And then we visualize based on the minimum and maximum values we are seeing here, okay? So the minimum value we are seeing here is basically below 0.2. So we can say maybe 0.15, right? And then the maximum value we are seeing is almost 0.6. So we can say 0.65 or just 6, or even this is 1. We can even limit them between 1 and 6. No problem with that. Okay, then we don't provide any palette because we want it to be gray, that is black and white. Why do we want it to be black and white? It's maybe a better way of seeing night light, because we are representing night light, right? So we are working in a T-zone at night, and this is the kind of brightness you will be seeing. If we remove this and we see the background, we realize that this is an urban center where there is that high intensity of light, which is pretty white. It's an urban center or a shopping center or a small market up there, okay? On the other hand, if we go to the sugarcane zone, we also see some spots of brightness. Maybe this is also a big roundabout here with a center here. There is a center there, and the other one is towards this end. There is also a small center here in roundabout, and then there is another center on this end. Maybe small center, not so much. But the brightness generally, it's way darker in this sugarcane growing zone than in tea growing zone. So if you're planning for electricity distribution or something like that in these 2 zones, you better enhance it within the sugarcane zone so people can travel freely or at night or something like that, or improve the light intensity there. Of course, from this plot, we see that there has been improvement since 2013. People are getting, lighting is improving between the 2 regions. And actually in 2024, they are almost coming close between the 2 zones. Sugarcane zone is catching up with the tea zone in terms of lighting at night. All right, so that's the end of this video today. I wanted to share it because many socioeconomic analysis would be interested in this kind of development indicators between 2 regions. It doesn't have to be sugar and tea. It can be whatever categorization you're using, maybe dry regions or wet regions or whatever, whether you want to compare lighting in Kenya and Uganda, it doesn't matter. The procedure is always the same. Okay, thank you for your attention. I'll leave this script, the link to this script in the description of this video. You are welcome to go and use it for your own region of interest. Remember to cite all the data sources and packages you use accordingly, because the authors really do a lot of work to get you going. Okay, so that's the end of it today. Thank you and happy coding. Bye-bye.